Good morning everyone, and welcome today for a webinar on the introduction to the vapor phase soldering technology. So let me first make a short introduction on the technology itself before presenting our VS500 system with a short demo, and then I will answer your questions. So regarding the technology itself, the vapor phase is the utmost technology for soldering. The principle is to use vapor created by a medium. Generally, it is Galden that we use, which is PFPE chemical product. So the idea is to transfer a uniform heat to the components to be soldered, so PCB, alloys, and package elements. This vapor gives a lot of benefits to the solder process, and we can classify these benefits in mainly 6 topics. So the first benefits of this technology is uniform heat distribution. The vapor used heats up the components smoothly with an homogeneous uniform heat. This reduces the risk of damages caused by excessive or unequal heat, which is often a critical issue with conventional and infrared soldering, including vacuum technology. So this ability to provide a heat transfer through the vapor is also great to deal with high thermal inertia elements while keeping a low stress level. The risk of some defects linked to the solder stress are therefore reduced, such as the Manafan effect. So the second benefit of the vapor phase technology we can talk about is the reproducibility. The Galden, which is the medium used to generate the vapor, has this particular ability to boil at a certain level of temperature and to be very stable, and you can't exceed this temperature. It means you will pick up the Galden type of the temperature you want to reach. For instance, you will be using Galden 240 to reach 240 degrees, or Galden 260 to reach 260 degrees. By controlling in the chamber the pressure and the temperature, we can reproduce the exact same conditions over cycles with very high precision. This ensures for you a consistent solder joint quality on every board. The third very interesting advantage is regarding inerting. It means removing the oxygen during the process to avoid any oxidation from the solder joints. This is what the system does with the Galden vapor that will replace the air and therefore the oxygen. This provides a longer lifespan of the solder joints, and it is also linked to the next advantage, which is the void reductions. So the fourth benefits of this technology of the vapor phase is the void reduction. It can reduce up to 90% the amount of voids created during the soldering process. This is a reduction compared to conventional reflow soldering. This means for most applications, voids will be a non-subject. Because you have very low amount of voids and you have no oxygen blocked in your voids, it means no risk of oxidation in the future or too much voids leading to a weak solder joint. So it means you have very high quality solder joints, very stable for electricity and mechanically. Even for the power electronics applications, this is therefore a compatible technology. For information, the IPC recommends for the voids to be able that you need to be able to control the amount of voids, means to have an average same amount over your process, having a good repeatability, because this means you have a control over your process, what we do have here with the vapor phase technology. So the only applications that could be in favor of a vacuum technology, which is often compared or combined with the vapor phase technology, is for heavy environment air pressure. Means if you have your boards that will be used in an environment where air pressure will be extremely high. Otherwise, the vapor phase technology will be able to deal with all other applications. The fifth advantage that we can now talk about is of this process is that it is really easy to use. It means the process does not require specific settings for every board design, as you can usually do with conventional ovens. It means you are able to mix up in the same batch different boards with different shapes, different designs, and it will be successfully soldered. But of course, you need to be using the same solder paste for all your projects. I mean, same liquidus temperature on your solder paste. So this technique guarantee unrivaled simplicity of adjustment of the reflow profile compared with other soldering techniques, and it avoids any handling error during the soldering cycle by the operator. So finally, but not least, benefits of this technology is Galden is compliance with ROHS regulations, and it is also quite good in power efficiency, which are some aspects that more and more companies are concerned of. So let's now move on the machine itself to give you an overview. So let me introduce you this device, and then we will show how easy it is to use it to process some boards. So here you have our device named VS505. This system is assembled here at our premises in Buc, so it's in France. The machine provides you with a working area of 500 by 500 millimeters. This is a very compact and standalone device. It just does require power supply to be connected to the machine, of course, and you just fill it with Galden, and then you can simply run it. The device is composed of a lead with a very large ESD safe window, which gives availability to the operator to see the process directly. The lead is maintained by 2 gas springs, which prevents the operator from hammering his hands, and it also prevents the operator from closing the door too abruptly, which could shake the components and make some production defaults. So you can see the lead here is standing in the position where you leave it. This is for safety and convenience. While talking about the ergonomics, the machine is fitted with a light tower and a buzzer, of course, so it lets the operator know the status of the process. Here you have a large HMI color display, which is very ergonomic and provides you with all the data. It will all the production data. On the side, you have sockets for thermocoupled connections. It is pass-through connections, means here on the inside you can connect your probe, thermocouple, and in the outside you can connect your data logger to recover the temperature from the process. This is very useful, especially for ISO compliancy, to record production data for traceability. for the data themselves, you can here plug a USB stick and recover the production data from the PLC, including Galden temperature and the real temperature at the side of the PCB, because we have a thermocouple here mounted on the lift. So here from the inside you can see the lift. The lift is now in the upward position, so closed. It is closing the process chamber. The principle with the Galden is that we are heating up the liquid Galden underneath, that is in the process tank, and it builds up the vapor. Once the vapor is generated and the lid is closed, the elevator goes down to the process chamber, where the vapor covers all the parts to be processed. Once the parts are processed, the lift will go up and close again the process chamber for the cooling and the Galden recovery step. The system does have a vacuum pump that is sucking the vapor out of the tank to condensate, so that when the lid is opened at the end of the full process, you don't get the Galden to be lost in the air. So then, the key element for the good vapor phase process lies mainly on the chiller. We are using the chiller to constantly cool at the top of the tank, even during the heating process, to create a really high pressure area to press, to make pressure on the heated Galden. So this is why we are using the SMC industrial chiller, which are very efficient and easy to maintain. It is a closed loop on the fluids, and it is fitted with self-diagnosis, so maintenance is very easy and is to be carried out only once a year. So let's now jump to the demonstration. So in order to keep our webinar within a reasonable time frame, we have already heated up the system to idle. So it takes approximately from 12 to 15 minutes to get from room temperature to idling, and it mainly depends on the Galden type used. So as we mentioned before, the vapor phase system gives its great ability to have different boards with different designs to be processed inside the chamber at the same time. So we have here, for instance, the same board that we have prepared, but one is with blue solder mask and the other one is without any solder mask, and all the copper shield has been kept. It means different thermal inertia for both boards. In addition to this, we're adding some aluminum parts on top of which we are adding some solder to see if it does succeed to to create to solder. So the solder paste we are using here has a liquid use of 217 Celsius degrees. Then we check, we go for checking our settings. Here we are using the Galden 230, so we select the corresponding Galden on the software, and we have different settings available. So regarding here the soak zone temperature and the soak zone time, this is, let's say, a preheat stage for the board before heating up to the liquid use stage. And the gain factor is a heating ramp. So after this stage, we have the liquid use stage that is here mentioned as peak zone time and peak zone gain factor. The temperature is not to be set by the software because it is determined by the Galden you are using. So the peak zone time is a time to remain at the Galden temperature. In our case, it means it will remain at 230 degrees for the mentioned time. and the gain factor is the ramp to reach this peak temperature of 230 degrees. Then we have the time vacuum and fan. These are the settings for cooling and Galden recovery. It means the longer time you set, the more Galden you will simply recover. So we can now close the lid and press the start button to start our cycle. So now we can see the elevator goes down. So when going down, the air from the top of the lift mixes up with the vapor, leading the vapor to decrease in temperature. Also, the vapors that get in contact with the boards and components condensate at this time, because these elements were colder compared to the colder than the vapor itself. This liquid Galden on top of these elements will give an additional protection against the oxygen during the process. So at this stage, the system is now heating up the Galden to recover the set temperature, let's say the preheat stage. On this main screen, you can see the stage where we are now. This gives the total time since the start of the cycle and the remaining time before the next step of the cycle. So we will move now to a video we have recorded of this process that is fast forwarded, because real time process takes approximately from 14 to 16 minutes. So that would make our webinar too long. Now it is heating up to reach the peak temperature. The liquid state has been reached and the solder is done, so the lift will now go up to start the cooling process. Now the lift is closed, so vacuum starts to recover the Galden for a few seconds. Now the fans are activated. This helps the vapor to move around and get in contact with the cold panels on the side to condensate. Our full process is now done. We can open the lid and get our parts for inspections. We can see that even on the aluminum parts, the solder has been processed. Here are the parts from the cycle shown on the video. Let's check with the microscope to get a better magnification. We can see that the solder joints have been have a perfect shape, and on both PCB board designs. So we have finished now with the presentation of the machine and the technology, and we are moving to the questions. So you are invited to ask your questions directly in the chat, which is available on the YouTube page, and my colleague will read the questions for me. So Marco, do we have any questions for now?
Actually not, we are waiting.
Okay, maybe we'll wait maybe 1 or 2 minutes.
Yes.
Or maybe it was clear enough and no questions. Let's see. In the meantime, I can invite you to join us for the next week. If you are attending Electronica, we will be exhibiting this exact machine on our booth in Munich, in Germany, on the hall B1, booth 143. So if you have any chance to visit us, you will be welcome, and we will have more possibilities to discuss the technology and the machine itself. So any questions now?
Yes, I think so. We have one question. Thank you for the question. They want to know if you can explain a little bit of the maintenance procedure, or what is needed to make a maintenance I think it's an interesting question.
Yes, thank you. Thank you, Marco. Thank you for your questions. So the maintenance basically on this machine is pretty handy, pretty simple. The first things to know is it will depend heavily on the use you are making on the system itself. So let's talk about the case that covers most of applications. Customers using a no clean flux. If you are using no clean flux, maintenance will depends on number of cycles you are doing. It means after 100 cycles you will get a pop-up information on the machine asking you to do the maintenance. So the basic maintenance is basically cleaning of the process tank. It takes roughly 1 hour. You need to drain using a manifold that is on the machine. You need to drain the Galden that is inside, clean the tank, and then fill it again. And then you've got the yearly maintenance, which contains a full cleaning, of course, the filter cleaning and replacement, and also the oil from the vacuum pump replacement, and the water from the chiller needs to be replaced also once a year. And we can of course advise on a daily routine, on a daily morning, just to have a quick not maintenance but a quick inspection, view inspection around the machine, see if everything is in order before starting. That is. Any other question?
Okay, thank you, Alexi. Yes, I have here one question. It's from Lucien. I can't understand what you mean. What kind of? I don't know what he wants to say. Okay, I have here another question. Perhaps we can follow with this one. How can we check the Galden level?
So this is a really good question. The machine is not fitted with a Galden level itself, which tells you the exact amount that is remaining inside, but we are using the software to detect the lake of Galden inside, and once the Galden reaches a certain level, which is about 4 liters of Galden remaining, the machine will pop up an alarm to the operator to tell him just to refill 1 liter at the end of the current cycle. So it means once you get the pop-up, you need to top up with 1 liter each time. Full tank capacity 5 liter. When you go down to 4, it asks you to put 1 liter more. It's really simple, and no any misuse can be done with the quantity inside. Then hope it answer the question.
Yes, I think it's clear. Now I got the question from Lucien. It's now clear for me. He wants to know what cleaner or what type of cleaner is needed for the cleaning procedure.
So for the cleaning procedure, we are you have different possibilities. It depends also on the flux you are using. So I will not talk about the resin flux, which is a little bit different, but doesn't cover most of the cases, except maybe if this is a question. But for no clean flux, most of the time what you need to do is use isopropylic alcohol, so pure alcohol that you can spread. If you clean it really often, it will be enough. If that is not enough, which can happen also sometimes, and you need to be a little bit more aggressive, then you can use reflow oven, standard reflow oven solutions for cleaning that are available on the market, and this will help to clean it completely, the tank.
Okay, thank you. Another question is if it is possible to use to make lead soldering.
Yes. So the lead soldering is possible, and in that case we would recommend the customer to use the Galden LS200. The liquid use of lead soldering is 189 degrees Celsius. So when you want to operate at this temperature, we recommend to use Galden 200, which means the machine will rise up to 200 degrees and will make the solder possible.
Okay, thank you, Alexei. More question. Let me check the chat. Here I have found an interesting question. If we have double sideboards,
Yes.
can we handle it?
Yes. To handle a double sideboard, it's quite easy with a vapor phase system, because you can use even any kind of support for the board in aluminum or whatever material that can withstand the heat and the chemical, of course. So if you, for instance, use aluminum bar, it will lift up a little bit your board. You can put it on top of it and go for the solder process, and it will work. And otherwise, you have a real professional solution. I will show you. It's a carrier that you can use, universal one, where you can put your board directly on top of it. Then you put it into the machine, and it will be a little bit lifted, so you can do the double sideboard with this. Any other question?
Let me check this question we had.
Or if any question is not clear enough, you can also
yes, please.
In the chat ask for more clarification,
yes.
and of course I will try to go a little bit more in depth.
Okay. Here one question. It's about the cycle time. How much Galden does the machine use per cycle? Do you understand?
Yes. So the Galden quantity that is used during a cycle will depend on the board design and the Galden type used. So when I say that, I don't answer any the questions, but let's say on average, if you are doing the board we have done today, so not too much, not very large, not too many components on the board, average will be about 10 grams per cycle. What will make the difference also with one same design is the amount of time you keep the recycling process on at the end of the cycle. This can be adjusted from now. You don't want to recycle any of the Galden, or to a longer extended time to recover the maximum Galden possible. But on average, for simple board, we are from 10 to 12 grams per cycle when we optimize it.
Okay, thank you. Now a little bit funny, there's a question from Lucien again. Thank you, Lucien. We were discussing this morning about this question in our meeting. Lucien wants to know, do you have also an inline model, or is there something planned maybe?
No, at the moment we don't have inline systems because we have developed this offline one, and for the time being the requests from our side of inline systems are not high enough to go for a full development of a new system. Maybe it will come in the future, but this is not the case to date.
Okay. Thank you. So for the moment I don't see more questions. Maybe you have some
For me,
advices or experience to tell to our viewers?
the best for our viewers, if they want good experience, is to come.
Yes, yes, for sure.
Meet us in our demo room, have a test on the machine, and I think this is the best way to experience the technology and experience the product.
Okay.
So still no more questions?
No, at the moment I do. Let me see. Yes, there's one more. Oh, sorry, I didn't read it. If it's possible to use different types of Galden on the same machine, so one machine, different types of Galden?
So we can use different types of Galden on the machine, but not at the same time, and it needs a little operation. We have only one tank for the Galden, so it means when you want to use different Galden, you can do it, and you need to flush, just to remove the first Galden which is inside. This is a really quick process, takes approximately 10 minutes only, and then you fill with the new Galden. And then in the software, of course, you can use any type of Galden that are available on the market. You can select the one you have filled the machine, or even you can use a function that is on our machine that is called AGS, which is a function that will detect automatically the type of Galden you have filled inside the machine. So the machine is completely capable of using different type of Galden, and that is.
Okay, thank you. So for the moment, no more question. I think it was quite a lot.
Okay, it was really good.
Thank you very much.
So thank you everyone for attending our online webinar. If you have any questions, even after this event, please feel free to contact us. It will be a pleasure for our team to give you the questions you have, the feedback you are expecting. And if by any chance you are attending Electronica next week, please give us a visit, and we will be more than happy to show you the machine. I wish you a very nice day, and I hope we can meet again in a next event. Goodbye.
Okay, thank you. Goodbye.